Okay, so in the last video we talked about linear transformations and what they are and how to find them, or well, tests for them really. So I want to quickly talk about how we can find the matrix of a linear transformation. So what I mean by the matrix of a linear transformation is that if I have some linear transformation T of V, there's some matrix A so that I can multiply that with V and I'll get the same solution both times. So this is some matrix. Okay, so well, how do I find this? Well, one thing we need to know is we need to know what the standard basis vectors are. So we call these E1, E2, up to En whenever we are in R to the n. Okay, and so what they look like, for example, if we're in R2, we're just going to have 1, 0, 0, 1. If we're in R3, we're going to have 1, 0, 0, 0, 1, 0, and 0, 0, 1. So they're just ones in each row and then zeros everywhere else. So for each one of these, there's a 1 in the ith column. So for EI, it has a 1 in the ith column, ith row, and 0 elsewhere. Okay, so they just look like that. So notice that I can take E1, E2, up to whatever, and I get in a matrix, and I'm going to get the identity matrix for Rn. Super cool. So when I want to find this matrix here, it's actually super straightforward. So for each one of these vectors, all I'm going to do is I'm going to take T of E1 and then T of E2, etc. Excuse me, that's just the dog. You're okay, honey. All right, she's done her thing. Okay, so we're just going to take the linear transformation of each of these standard basis vectors. So from our example from the previous video, we had this. We were in R2, and we had V1 plus V2, V2. Okay, so if I want to take the standard basis vector, I'm going to take, notice I'm in R2, so I'm going to have 1 and 0. So the top one's going to give me 1 plus 0 and 0. So 1 and 0. The second one, 0 and 1. I know this one isn't very exciting. 0 and 1. Well, again, on the top, I'm going to get 0 and 1. So I'm going to get 1, and then I get 1 on the bottom. So my final matrix is going to be 1, 0, 1, 1. Okay, and this is going to be matrix A, so that T of V is equal to A of V. Okay, so I plugged in my standard basis vectors. I'm in R2 here. So I only needed the standard basis vectors for R2, which up here we said were just these two. Took them, and then I put them one at a time. I did E1, and then I did E2, and that's how I formed my matrix. And that's about it. So it's super quick, but I didn't want to include it in the last video because it's a little bit different.